National Electrical Code Section 422.6c mandates the use of shunt trip coils for all kitchen equipment that produces heat from electricity. This requirement is applicable to a wide range of cooking appliances commonly found in kitchens, including ranges, ovens, cooktops, and fryers. The primary purpose of incorporating a shunt trip coil into these appliances is to provide an automatic means of disconnecting the appliance from its electrical power source in the event of a fire or other emergency situation. The shunt trip coil is designed to be connected to a fire alarm system or a heat detector, which serves as the triggering mechanism for its activation. When a fire alarm is triggered or a heat detector senses an abnormally high temperature, the shunt trip coil receives a signal that prompts it to trip the corresponding circuit breaker or fuse. This action effectively cuts off the electrical power supply to the appliance, thereby mitigating the risk of further fire escalation or potential electrical hazards. The inclusion of this requirement in the National Electrical Code reflects a proactive approach to enhancing electrical safety and preventing fires and injuries in kitchen environments. By ensuring that kitchen equipment can be quickly and automatically de-energized in the event of a hazardous situation, the risk of electrical fires and associated injuries can be significantly reduced. The shunt trip coil serves as a critical safety component, providing an additional layer of protection for both property and occupants. Consider a scenario where a deep fryer malfunctions and the oil begins to overheat, posing a significant fire hazard. In a kitchen equipped with the shunt trip system, the heat detector would sense the excessive temperature and immediately activate the shunt trip coil. This action would trigger the circuit breaker to trip, cutting off power to the deep fryer and preventing the oil from igniting or causing further damage. Without the shunt trip system, the deep fryer could continue to overheat, potentially leading to a full-blown fire that could spread rapidly throughout the kitchen and beyond. The National Electrical Code's requirement for shunt trip coils in kitchen equipment is intended to address such scenarios and provide a reliable means of preventing electrical fires and protecting lives and property. The specific requirements outlined in National Electrical Code Section 422.16 provide detailed guidance on the installation and application of shunt trip coils in kitchen environments. These requirements cover various aspects, including the types of appliances that are subject to the rule, the proper wiring and connection methods, and the testing and maintenance procedures that should be followed. By adhering to these requirements, electrical contractors and kitchen equipment installers can ensure that shunt trip systems are properly implemented and function effectively in the event of an emergency. It is essential to note that the National Electrical Code is a comprehensive set of standards that is updated periodically to reflect advancements in technology and evolving safety concerns. Therefore, it is crucial for electrical professionals to stay abreast of the latest code revisions and interpretations to ensure compliance with the most current requirements. Furthermore, it is important to consult with local authorities and building inspectors to confirm any additional requirements or interpretations that may be specific to a particular jurisdiction. In addition to the National Electrical Code, other relevant standards and guidelines may also apply to the installation and maintenance of shunt trip systems in kitchen environments. These may include standards from organizations such as the National Fire Protection Association and the American National Standards Institute, as well as local building codes and regulations. By taking a comprehensive approach to understanding and complying with all applicable requirements, electrical professionals can ensure that shunt trip systems are properly designed, installed, and maintained to provide the highest level of safety and protection. The implementation of shunt trip coils in kitchen equipment is a proactive safety measure that can significantly reduce the risk of electrical fires and injuries. By automatically disconnecting power to appliances in the event of an emergency, these systems provide a critical layer of protection for both property and occupants. The National Electrical Code's requirement for shunt trip coils reflects a commitment to electrical safety and a recognition of the importance of preventing fires in kitchen environments. It is therefore essential for electrical professionals, kitchen equipment installers, and building owners to understand and comply with these requirements to ensure the safety and well-being of all. Let's delve further into the technical aspects of shunt trip coils and their integration within kitchen equipment electrical systems. A shunt trip coil is essentially an electromagnetic device designed to remotely trip a circuit breaker. The coil is energized by an external signal, typically from a fire alarm system or a heat detector, causing it to mechanically release the circuit breaker's latching mechanism, thereby interrupting the flow of electricity. Shunt trip coils are often used in conjunction with circuit breakers that are specifically designed to accommodate them. These circuit breakers have an internal mechanism that allows the shunt trip coil to directly interact with the tripping mechanism. The shunt trip coil is typically wired to a normally closed contact in the fire alarm system or heat detector circuit. In normal operating conditions, the contact remains closed, allowing current to flow through the shunt trip coil and keep it energized. However, when a fire alarm is activated or a heat detector senses excessive heat, the contact opens, interrupting the current flow to the shunt trip coil. This loss of current causes the coil to de-energize, which in turn triggers the circuit breaker to trip. The shunt trip coil is usually rated for a specific voltage and current, which must match the voltage and current rating of the circuit breaker and the control circuit. It is essential to ensure that the shunt trip coil is properly sized and compatible with the other components of the electrical system. The installation of a shunt trip coil should be performed by a qualified electrician who is familiar with the National Electrical Code and other applicable standards. The electrician should carefully follow the manufacturer's instructions and ensure that all wiring connections are properly made and secured. The shunt trip coil should be mounted in a location that is accessible for inspection and maintenance. It is also important to protect the shunt trip coil from physical damage and environmental factors that could affect its performance. Regular testing and maintenance of the shunt trip system are crucial to ensure that it functions properly in the event of an emergency. The testing procedure should involve simulating a fire alarm or heat detector activation to verify that the shunt trip coil triggers the circuit breaker as intended. The maintenance procedure should include inspecting the wiring connections, cleaning the shunt trip coil, and verifying that all components are in good working order. The National Electrical Code provides specific guidelines for the testing and maintenance of shunt trip systems. These guidelines should be followed carefully to ensure that the system remains reliable and effective. In addition to the technical aspects of shunt trip coils, it is also important to consider the human factors involved in their implementation. Kitchen staff should be trained on the purpose and operation of the shunt trip system, as well as the procedures to follow in the event of a fire or other emergency. Emergency contact information should be readily available, and staff should be familiar with the location of fire extinguishers and other safety equipment. Regular fire drills should be conducted to ensure that staff are prepared to respond effectively to a fire emergency. The implementation of shunt trip coils in kitchen equipment is a collaborative effort that requires the involvement of electrical professionals, kitchen equipment installers, building owners, and kitchen staff. By working together, these stakeholders can ensure that shunt trip systems are properly designed, installed, maintained, and operated to provide the highest level of safety and protection. Now, let's explore some of the specific challenges and considerations that may arise when implementing shunt trip coils in different types of kitchen equipment. For example, in the case of commercial ranges and ovens, the shunt trip coil may need to be integrated with the appliance's existing control system. This could involve modifying the wiring or adding additional components to ensure that the shunt trip coil can effectively disconnect power to the heating element. In the case of deep fryers, the shunt trip coil may need to be specifically designed to withstand the high temperatures and greasy conditions that are common in fryer environments. This could involve using special materials or coatings to protect the coil from damage. In the case of dishwashers, the shunt trip coil may need to be integrated with the appliance's water level sensors to prevent the dishwasher from operating if the water level is too low or too high. This could help to prevent damage to the appliance and reduce the risk of electrical hazards. In all cases, it is essential to carefully consider the specific characteristics of the kitchen equipment and the environment in which it will be used when selecting and installing a shunt trip coil. By taking a customized approach, it is possible to ensure that the shunt trip system is properly integrated and functions effectively in the event of an emergency. It is also important to note that the National Electrical Code may have different requirements for shunt trip coils depending on the type of kitchen equipment and the specific application. For example, the code may require that shunt trip coils be installed on all cooking appliances in commercial kitchens, but not necessarily on smaller appliances in residential kitchens. It is therefore crucial to consult the National Electrical Code and other applicable standards to determine the specific requirements that apply to a particular situation. The proper implementation of shunt trip coils in kitchen equipment is a complex task that requires a thorough understanding of electrical systems, kitchen equipment, and applicable codes and standards. It is therefore essential to engage qualified professionals who have the expertise and experience to perform the work safely and effectively. By investing in proper design, installation, and maintenance, building owners can significantly reduce the risk of electrical fires and injuries in kitchen environments and create a safer environment for their employees and customers. The role of the authority having jurisdiction, often referred to as the authority having jurisdiction, is also of importance. This entity could be a local building inspector, fire marshal, or other designated official responsible for enforcing codes and standards. The authority having jurisdiction has the authority to approve or disapprove electrical installations, including those involving shunt trip coils. It is crucial to consult with the authority having jurisdiction early in the planning process to ensure that the proposed installation meets all applicable requirements. The authority having jurisdiction may also have specific interpretations or requirements that go beyond the National Electrical Code. It is therefore essential to be proactive in communicating with the authority having jurisdiction and addressing any concerns or questions that they may have. By working closely with the authority having jurisdiction, it is possible to ensure that the shunt trip system is properly designed, installed, and inspected, and that it meets all applicable requirements. The National Electrical Code is not a static document. It is updated regularly to reflect advancements in technology, changes in industry practices, and evolving safety concerns. It is therefore essential for electrical professionals to stay abreast of the latest code revisions and interpretations. There are several ways to stay informed about changes to the National Electrical Code. One way is to attend continuing education courses offered by professional organizations such as the National Fire Protection Association and the International Association of Electrical Inspectors. Another way is to subscribe to industry publications and online resources that provide updates and analysis of code changes. It is also important to participate in local code development processes and provide input on proposed changes to the National Electrical Code. By actively engaging in the code development process, electrical professionals can help to ensure that the code reflects the latest knowledge and best practices in the industry. The implementation of shunt trip coils in kitchen equipment is an ongoing process that requires continuous learning and improvement. By staying informed about the latest codes, standards, and technologies, electrical professionals can ensure that they are providing the highest level of safety and protection to their clients. In summary, the National Electrical Code's requirement for shunt trip coils in kitchen equipment is a critical safety measure that can help to prevent electrical fires and injuries. By understanding the technical aspects of shunt trip coils, the applicable codes and standards, and the human factors involved, electrical professionals can ensure that these systems are properly designed, installed, maintained, and operated to provide the highest level of safety and protection.